Welcome to the Network Engineering Video Blog. I'm your host, Michael Crane. Today I want to talk about building some Ethernet cables, specifically gigabit Ethernet cables. I realize making Ethernet cables is not a normal network engineering job, but I think it's important to be able to identify the different cables, the straight through, the rollover, and the crossover, so you don't look like a dope when you're on site and trying to dig through a box of cables and you can't tell a T1 from an Ethernet cable or a console cable. So I think it's real important to learn. Even if you don't learn how to make them, you should be able to identify them. I went ahead and I drew some cables out, and I want to call these, let's just call them RJ45 cables for right now, because, and I'll explain later. But so we got three different kinds. You have the straight through, the rollover, and the crossover. Now you probably are thinking, yeah, he's kind of lost his mind if that looks straight through. But really, if you take a look at it, you've got pin 1 is matched to pin 1. Is that better? So you got pin 1 is matched to pin 1, 2 is mapped to 2, 3 to 3, 4 to 4, etc., all the way up to 8. And on the rollover, you've got 8 to 1, 7 to 2, 6 to 3, 5 to 4, and so forth, all the way down. So you can see that it's actually reversed. And on the crossover, I kind of drew it out into a block to see if it could make it a little more easier to read, and as you can tell, that is not a real easy way to read that. This is not the way to draw Ethernet cables in any kind of a document, and I'll show you why, and the proper way to do that here in just a second. One of the reasons why I said RJ45 cable is because you can use a straight through cable as a console cable, like a serial console cable. And you can use a rollover cable as a serial console cable. But you cannot use a crossover for a serial console cable. You can use a straight through as a Ethernet cable. But you can't use a rollover as an Ethernet cable because the pinouts aren't the same. And that's where the crossover comes in. So really, the straight through and the crossover are really the only real Ethernet cables that is on this board. Although the rollover does come in handy for some console applications, so I just went ahead and drew it up there just to kind of show you the difference between a straight through, a rollover, and a crossover. Some people confuse these two terms, a rollover and crossover. I'm actually one of them. I used to do it all the time and always got corrected by the lab ops guys. But yeah, this is, when you're talking crossover, it's a different animal than a rollover. So you don't look at RJ45 cables like that. That's the way the drawing is up on the. This is a straight through cable, and I don't know if this is focusing in, but this is a straight through cable. And it's laid out like the top one up on the board, and this will just confuse you. The way you look at RJ45 cables is you turn them around and look at them like this, and I hope you can see that. And this way, so now you can see, if you look at these, that the white and the white orange and the white orange are both on the left. So really you need to read these, or look at these cables, or read them, if you will, from left to right. So pin 1 is on the left of both of these. So you got white, orange, orange, white, green, blue, white, blue, green, white, brown, and brown. And the exact same thing is on the other side. So within seconds, by holding a cable like this, you'll be able to see, oh yeah, that is truly straight through. Okay, so this is, I redrew this so we can talk about them the same way you'd want to look at them in your hand. And like I said earlier, you want to hold them up side by side, both ends of the cable, and then just start looking at, okay, so the easiest one to straight through is probably something you're going to build 99% of the time. And that is, and it goes white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. And it's identical on both sides. And it looks a little bit strange, and the reason why is because back in the olden days, you didn't really need all these. You needed white, orange, orange, white, green. We didn't use blue. We didn't use white, blue, and we didn't use brown or white, brown, and brown. And these wires, I guess for the way they're built, there's some kind of the way they're twisted, needed to be separated like that, and you could probably Google around and figure out what the reason why it was done like that in the first place. But you can, and actually you can still build cables like this. You don't need these others, except the problem is this cable will not pass gigabit traffic. I think the most you'll be able to get out of a cable made like this with 1, 2, 3, and 6 is going to be 100 meg. So that's one drawback. Another drawback is it won't, if you have any kind of power over Ethernet devices, that's not going to work. This is not a recommended way to make cables anymore, and I highly discourage it. So one other thing to also note on this straight through cable that I wanted to bring up is if you're ever building a cable, and I know this looks kind of confusing. It's like white, orange, orange, white, green, blue, then white, blue, then you stick the green all the way over here, and these are reversed, and and it's like you're thinking, why isn't it just white, orange, orange, white, green, green, white, blue, blue, and et cetera, et cetera. And like I said, there's a method to the madness of this wiring. I'm sure it has to do with the way Ethernet wire is twisted and for balancing electric signals and that sort of stuff. I don't know. I'm sure if you Google around, you could probably dig up the physics behind it. But one of the things I wanted to point out is you notice it goes white, orange, orange, white, green, blue. So there's always a striped wire and then a solid wire. Striped wire, solid wire. Striped wire, solid wire. Striped wire, solid wire. Solid color. And that's also another way. If you're looking at an Ethernet cable in your hand and you see two solid colors right next to each other, you don't even have to know the pinout, because you know something's not right. It's either not an Ethernet cable or it's been made wrong. On a rollover cable, it's pretty simple. It is it's basically just a mirror reflection of this side on this side. And so what do I mean by that? So we've got one white orange on pin 1 here. So that's going to move to pin 8 over here. And then orange will be on 7. White green will be on 6. And blue. And then white blue. And then green, white brown, and then brown. As you can see, it's basically just taking these wires and just flipping them around like that. So that's a rollover. That's pretty simple, and you'll see those a lot of times for serial cables. Okay, so the last cable we're going to look at today is going to be the crossover cable, and then we'll go to the workbench and build something. So. The crossover cable, if you remember when I was talking about the straight through and said, well, we really only needed 1, 2, 3, and 6. So let's take a look at that. And the way this works on an Ethernet cable is this right here is transmit, and these two here are receive. So yeah, so on a straight through it's the same. You got transmit and then 3 and 6 are your receive. That's fairly normal for when you're connecting, let's say, a computer to a Ethernet switch. The Ethernet switch is already rolled over internally. And even nowadays, it doesn't matter. You can, most switches will automatically roll themselves over if they see that they're flipped around, if they have both transmits are connected to each other. The point of a crossover cable is, and you won't probably hardly make these anymore, but in the olden days, before Ethernet switches and Ethernet interface cards were smart enough to roll themselves over, you had to build these crossover cables. And what a crossover cable does is it basically maps the transmit to the receive. So if this is the transmit and these two are the receive, let's see, transmit, receive. What we're going to do is we're going to map these guys to we're going to map the transmit to the receive. So it's going to go white, orange, and then orange, and then we're going to do white, green, and green. Okay? And that way the transmit from this side is going to the receive of this side. So, and that happened a lot if you're like connecting two computers together. They were both set up thinking they were going to be connecting to an Ethernet switch, not to another computer, and so you would have to build like these crossover cables to switch it over so they would communicate properly. And but like I said, nowadays with all the new NICs, they automatically do that for you. So you probably will never have to build one of these. But if you run into an old piece of equipment or you see a cable that doesn't look right, you'll know exactly what it is. Now you might be wondering, okay, so we move the transmit to the receive, and over here, and why didn't we roll over or switch these two? You know, we switched the white orange to the white green, or you know, from pins 1 and 2 over here to pins 3 and 6. And why didn't we flip it around so like this would be orange and white orange, for example? And these things have a polarity, and I don't think it matters. You could probably flip these around, and the polarity, I don't think the polarity matters, because it's a differential input. So the inputs are looking for the differences in the signal. But most of the documentation you read is they keep the polarity straight on both sides. So, you know, for completeness, I just wanted to show you that. But explain, if you see something, if you see these guys flipped around like that, it's probably not going to matter. So, okay, so we've started building our cable. We've basically crossed it over. So and now we just need to add the rest of them. And the rest of them are going to be mapped exactly like the straight through. These don't roll over or cross over at all, they just go. So now you got blue, and then white blue, and then brown. Oops, sorry. You got white, brown, and then brown. And the same with this side, you got blue, white blue, and then brown. Very good. White, brown, and brown. Because like I said, you'll need these extra wires for to support power over Ethernet and gigabit speeds. Okay, so enough of the theory. So what do you need to build an Ethernet cable? Well, first and foremost, you need cable. And you want to get category 6 cable, but it's got a just a PVC coating on it, it feels like, and it has the 8 wires. They're all color coded the right way, and 23 gauge, it looks like, 4 pairs. UTP stands for Universal Twisted Pair. I don't know if you can see that or not. So you need the cable. One of the things that you really need is a good pair of crimpers and a crimping tool, and I highly recommend this. Let me see if I can zoom in on this. I highly recommend, oh, come on, I'm going to zoom in. I highly recommend this Easy Rj Crimper. And I'll show you why when we go to build it, because building Ethernet cables the old-fashioned way, where you had to stick them in there and kind of get them all lined up, is a real pain, and these guys have made it pretty simple to do. It's really quite nice. And you also need their but they do have it looks like a connector that goes along with them. They are a tad expensive, but it is well worth the money. Okay, so I'm going to try to build this on camera. So I want to build about a 6-inch jumper cable. These are something that you can't buy normally in the store, and instead of having, especially if you're going like from 2 pieces of equipment that are just right next to each other, I just want a small jumper cable between them. So I'm going to pull out my Easy RJ Pro multi-tool here, if you will, and they were kind enough to put a cutter on here for me, so I'm going to measure out, I don't know, about 6 inches on there, and then I'm just going to cut it. Okay, there we go. So I've got my 6-inch jumper now, and I might have made it a little, I probably should make it a little bit longer, because I'm going to be stripping some off for the connector. So let's make it, instead of 6 inches, we'll make it about I don't know, let's make it a couple inches longer on each end to compensate for stripping and putting the connector on it. So I'm going to cut a little bit longer one there. All right. So the next thing we're going to do is we're going to strip off some of the sheathing here so we can get to the wires. I don't know, about 1 inch or so off, and kind of twist this around, and as you can see, it does a really nice job. This tool here, and you can see right there, it's got a little blade in there, so when you crimp down on that, you just crimp down on it and twirl it around, and it's just deep enough to cut the sheathing out. And the next thing I'm going to do is I'm going to come around and clean this up. So I'm going to take my little side cutters and cut the strings off, and I think I said, oh yeah, so it's got a little piece of plastic in here that we want to trim out of there, And you have to be kind of careful when you're doing this so you don't cut the wires out. The next thing that you're going to do is you want to untwist all these wires and start putting them in order. So our order is white, orange, orange, and the next one is going to be let's see, white, green. You got white, green. Now the green's going to go on the other side of these blues, so I'm going to just kind of move it over there. Let me untwist these white blues here. So I'm just going to go, so it goes white, orange, orange, white, green, blue, white, blue, green. And then the last pair is going to go white, brown, brown. And you're going to yeah, so obviously this needs to be where it can fit inside that connector. So the next thing I'm going to do is now that I've got them all lined up in order, I'm going to start just kind of pulling on them and stretching them and straightening them out. And there's tools to do this. You can actually so you can take something and just kind of put it on there and pull these straight, kind of get all the kinks worked out of them. And so we'll do that. And you kind of have to, you'll get faster at it if you have to build a lot of these. And I've seen people use scissors and different tools to straighten them out, or I mean, you can just use your fingers. If you have to do a bunch of these cables, just using your fingers will really wear out your fingers. You'll be pretty tired by the time you're done doing it. So as you can see, I'm just kind of massaging them in place, kind of getting them in there, getting them lined up so they'll fit, and they all need to be like right next to each other so they'll fit side by side in the connector. Okay, so that looks pretty good, and you can double check your work, you know, make sure you got them all lined up, and I think that'll go in the connector. Let me grab one, we'll give it a shot. Okay, now you can try sticking these in the connector just like this. Oops, I gotta flip it around. You can try sticking them in there just like this. I would suggest, at least it's easier for me, is I like to trim them before I stick them in the connector. It's kind of redundant, and I'll show you why here in a second. But to me, it just makes it a little easier to get in the connector. Now these connectors actually have holes in the back side of them, which is the real key to the simplicity of this. So you're just going to stick the connector on it. You're going to have everything lined up. You're going to stick the connector on there, and you're going to just keep pushing that cable into the connector until everything just comes out the other side, and that blue sheathing is underneath this crimp point right there, because that's gonna, when we go to crimp it with the crimpers, it's gonna push down on that, and that's gonna hold your wire. And before we crimp it, we're gonna go and check it real quick just to make sure nothing has flipped on us. So we've got white, orange, orange, and then let's see if we can see this. And then we've got, where is it? Okay, we've got white, green back there. Let me spread them apart a little bit. Okay, so we got white, orange, orange, white, green, blue, white, blue, green, and then white, brown, and brown. So yeah, it looks like we're good to go. So now what we're going to do is we're going to put this in our Easy RJ Pro crimper, and it goes in like it goes in this side like that. Okay, so you see everything's popped out. This has gone flush on this side, so once it's all pushed in there and this is flush, then we're just gonna give it a crimp, and you notice that it actually trimmed these wires off for us, which is pretty nice. So we're gonna let go of it, pull it out, and voila, we've got a perfectly made Cat 6 cable. And believe me, that is a lot easier than some of the other ones that I've seen trying to put them together with plastic inserts, and oh, it can be a real pain in the butt. And this is pretty nice. Now it does leave a little bit of edge right there, and most equipment doesn't have a problem with that, but if it does, you might have to go to a different connector. But I think I've only, well, I can't think of any time that I've had a problem with it, actually, because you can see the little plastic connector right there actually is further out than the wires are cut. So I'm going to go ahead and do the other side off camera. Since you've seen how to do one, the other side is identical, and then we'll be done. One thing to remember while you're doing this, and I actually ran into this myself, so I wanted to show it to you, is you need to make sure that when you get ready to put the connector on, that you leave yourself plenty of room to hold on and keep the wires straight, because they need to be very straight going into the connector, and that's any of them. So when you get ready to put that connector on, they need to be in almost perfect alignment, and then you stick the connector on like that. And if you don't do that, these things will catch on all. There's a bunch of little holes in there, and they'll catch, and then you'll be forever trying to fix this. And actually, this one looks like one of them moved on me. Remember, I was telling you it needs to be stripe, solid color, stripe, solid color. See, I had two stripes, and I noticed it immediately because there was two stripes right next to each other. So yeah, so just as a quick first look, see, I was able to notice that right off. And now I'm going to take another look. So we got white, orange, orange, white, green, blue, white, blue, brown. White, white, blue, green, and then white, brown, and brown. And everybody looks like they're in the proper order here. So this one's ready to be crimped. I was timing myself, but I kind of screwed this one up. So it took me a lot longer because I had to actually strip more wire off, and or more sheathing off to make it longer so I could hold on to it. So yeah, that's a pretty short 6 inches. I might have to rebuild that again. I don't know. I'll give that a shot, and maybe next time I'll make it 10 inches long instead of 8 inches, and give myself a little more room. Because it's easier to cut, some of the little wires off. If you strip too much, it's easier to cut those off than it is try to make this wire longer. As far as I know, they still don't make cable stretchers. So anyway, there you go. Yeah, you should probably test this. I don't have a gigabit Ethernet tester. I've got a regular continuity tester. But you can plug it into your equipment and it should be just fine. I'm real confident in these connections and the Easy Pro tool. I'm sorry, the Easy RJ Pro HD tool. I've used this quite a bit. This saves me just a ton of time, and it saves me trips from having to run to the store if I don't have something. But if you like this video, please give it a thumbs up. Or if you have any questions, leave me a message in the comments, and I'll try to get to it as soon as I can. All right, we'll see you later.